Hello guys, welcome to Ramta Solutions. Today we are looking at your mole mass ratios in chemical reactions. Without any waste of time, let's look at this. So let's say we are given a balanced chemical reaction. Okay, given a balanced chemical reaction again, we're given a balanced chemical reaction, small letter A, capital letter A, plus small letter B, capital letter B, giving us product, small letter C, capital letter C, plus small letter D, capital letter D. Now, remember, the small letters are the coefficients of your substances A, B, C, and D. Okay? The capital letters are your substances. Now, when you are given this balanced chemical reaction, to relate the number of moles, you can say number of moles of substance A over its coefficient is equal to number of moles of substance B over its coefficient. It is also equal to number of moles of substance C over its coefficient. It is equal to number of moles of substance D over its coefficient. Okay? Now, having done this, then you can say you now have number of moles. All right, you now have number of moles. So now find the mass. Okay, now find the mass. So now, what we're going to do is we're going to say, we know that formula, number of moles equals to mass of your substance over the molar mass of your substance. Okay? So, this is what you are going to do. So, this question that we are doing now, it goes from, say, being given number of moles to finding the mass of that substance, or being given the mass of the substance to finding the number of moles, or vice versa. Okay, perfect. Now, proceeding, we have, again, in our example, we're still going to use the very same example we used previously. So we're going to say 6 mole of aluminum, okay, 6 moles of aluminum react with hydrochloric acid, okay, reacts with hydrochloric acid according to the following reaction. Oh, sorry, not according, let me just leave it here. The reaction is, what is it? The reaction is, let's look at it, aluminum, let's say in solid phase, of course, hydrochloric acid in aqueous phase, giving us aluminum tetrachloride in aqueous phase, let's say plus hydrogen gas. As you can see, this is not balanced, but we'll come to it. So now the question is, how much mass, or sorry, maybe we should say calculate the mass. Okay, how much mass, it's fine, how much mass of number 1 hydrochloric acid is required. It's okay. Number 2 of aluminum chloride that can be formed. Oh, sorry, can be formed. Let's just say can be formed. Okay, can be formed. 3 of hydrogen gas that can be formed as well. All right, that can be formed. Right? Perfect. Now, what we're looking at now is this. We're saying we know we have to balance this. So now let's try to balance it. to balance it. It seems aluminum are balanced. So let's try to, but the chlorines are not balanced. So if we put a 3, it will not be a nice one. So maybe let me try to put a 2 here and then a 2 here. When I put a 2 here, aluminums are balanced even here. The chlorines, 2 times 3, it'll be 6. So let me just put a 6 here. And then we have 6 hydrogens. Here we have 2. So 2 times 3. We have balanced the reaction. Right? Perfect. Now, the first question says, how much mass of hydrochloric acid is required? Okay? Let's see. Number one, number of moles of hydrochloric acid over what is its coefficient? It's 6 is equal to the number of moles of aluminum over its coefficient, which was 2. Alright? Perfect. So, the number of moles of hydrochloric acid is equal to number of moles of aluminum over 2 multiplied by 6. What is this? This is 6 moles. So number of moles of aluminum were 6. So 6 over 2 multiplied by 6. What is this? This is 18 moles of hydrochloric acid that are required. However, we know we are looking for the mass. So we know N equals M over mass star. Alright? This is what we know. So what is mass star hydrochloric acid? According to your periodic table, it's 1 plus 35.5. 1 plus 35.5, which is 36.5. Alright? Which is 36.5. Right. So, having done that, this is 36.5 gram per mole. So, going to the next page. From this formula, we can see that, from here we can see that mass is equal to N times mass star. But I'm not going to use this. But if you like, you can still use it. It's okay. Alright? I'm going to just use this as it is. So we have number of moles equals mass of, remember, number of moles of hydrochloric acid over mass of hydrochloric acid over mass star hydrochloric acid. The number of moles were 18. What is the mass? We do not know. What is molar mass? It was 36.5. Therefore, mass is 36, or maybe 18 times 36.5. What is your answer? Quickly take your calculator. Let's see. It is 18 times 36.5. So this is 657 grams. Okay? This is 657 grams. That is the mass of hydrochloric acid. Okay? That is the mass of hydrochloric acid. Okay? Perfect. Now, the second question said calculate the mass of aluminum tetrachloride or trichloride. Why am I saying tetra? Aluminum trichloride. Aluminum trichloride. So, let's see. Number of moles of aluminum trichloride over the coefficient. It was 6. It was 6, right? It was 6. Oh, no, it was 2. It was 2. It was 2. It was 2 over the number of moles of aluminium over its coefficient was also 2. So when I look at this, this is number of moles of aluminum trichloride. chloride is equal to number of moles of aluminum over 2 multiplied by 2. This is basically equal to number of moles of aluminum, right? Isn't it? So number of moles of aluminum trichloride. Number of moles of aluminum trichloride is 6 moles. All right, is 6 moles. Now let's look for Mr. aluminum trichloride. What is it? Mass of aluminum trichloride. Aluminum has molar mass 27 plus chlorine 3 times 35.5. I remember 35.5. Let's see. So we have 27 plus 3 into 35.5. This is 133.5 gram per mole. Right? This is 133.5 gram per mole. Now, to find your mass, number of moles of aluminum trichloride is equal to mass of aluminum trichloride over Mr. aluminum trichloride. We said the number of moles of aluminum trichloride were 6. So it's 6 moles. Mass of aluminum trichloride over molar mass was 133.5. Therefore, mass of aluminum trichloride is 6 times 133.5. In conclusion, your mass of aluminum trichloride is, our answer multiplied by 6, it's 801 grams. Okay, the mass of aluminum trichloride is 801 grams. Finally, we're going to look at hydrogen. Let's see its coefficient. It was 3. Okay, it was 3, yes. It says the mass of hydrogen that can be formed. I don't know why I have to say this, but it's okay. I'll just continue with it. So number 3, it will be number of moles of hydrogen gas over its coefficient, which was 3, is equal to number of moles of aluminum over its coefficient, which is 2. Thus, number of moles of hydrogen gas is equal to number of moles of aluminum over 2 multiplied by 3. What is this? Aluminum, it is 6 over 2 multiplied by 3. So what is this? This is 9 moles, right? This is 9 moles. Now, Mr. hydrogen gas, you add 2 times 1, which is 2 gram per, mole, right? Which is 2 gram per mole. Okay, perfect. Now, to find the mass of hydrogen gas, we will say this H2 over Mr. H2. Now, what was this? I think it was 9. 9 equals mass of hydrogen gas over 2. Now, mass of hydrogen gas is equal to 9 times 2. Thus, mass of hydrogen gas is equal to 18 grams. Right? It is equal to 18 grams. So this is how you perform your calculations. Okay, this is how you perform your calculations, and I hope you guys now have an understanding. So with that being said, it's a wrap. See you next time. Bye bye.